final, we'll cover chapter 7, 8, 9, 10. And in terms of some important topics, chapter 7 is about work design. So, we're going to measure work in terms of time, taking the work, for example, with the precision, meaning the accuracy, at the same time, confidence level in terms of 95, 99, those percentage, so that we can measure how many minutes we're going to need to test certain, or tasks, for example. Excuse me. And I think that's the main. There are a few other things in work design, and that's something we'll pay attention to, so I'll show you the example. But chapter 8 is about location planning, so that we can determine which location is the best, given different criteria. For example, costs. We're going to have a revenue in terms of price per given, profit out of those, information given, so that we can calculate costs, profit, revenue, so that we can decide based on those calculations for the location. Chapter 9 is about management quality. It's more of how you're going to show those quality into graphical interface, like using check sheets or Pareto chart. It's kind of a histogram. So that's something we have worked on. So that's a part of it. Chapter 10 is about quality control. It's more of quality, so that this is continuation from chapter 9. It's a simple way of putting those quality data into worksheets, but here's other types of charts. We're going to work on X bar, R bar. This is showing the mean, sample means, and R chart is showing the range, meaning the difference between maximum and minimum values. And also P chart is about not just raw data, but we can also calculate the proportion or fraction, so that we can use those fraction and put it into the chart, so that we have idea of what are the upper level or lower level for the given samples, so that those quality are in control or not. So those are the chapters that we have, chapter 7, 8, 9, and 10. And in terms of specific questions that I have in mind from chapter 7, let me check whether I'm recording this. Yeah, okay, good. So out of chapter 7, this is the one, right here. So if you recall, we're trying to measure how many times we have to test for certain, item here. The item that we're trying to do is measure the time for the per certain tasks. I don't know what exactly it was. I'm not sure this is the entire question, but I think it's, I think that's it. But it could be anything, just measure the time to take certain tasks, to do any time the work in the factory. So you have 6, that's what they call 6 cycles. Okay, they don't call it, time. They don't call it a observation. They call it cycles. So which is pretty much the same thing. So how many work cycles should be time, so that whatever we're going to do it in terms of random sample, that can be within 2% of sample mean. That's the accuracy, right? So that we can kind of estimate those accuracy from the sample mean, and also the confidence level of 99%. So it's something to do with the normal distribution, if you recall. Because it's anything comes up with the confidence level, and then you have sample mean and standard deviation, that's more likely you're talking about normal distribution. Because at 99% confidence level, I think you should have a much higher number of observation or work cycle in this example. So 99% just, I think it's like 2 point something, 2.76, which is just, we use all the time. And if it's going down like 95% off, obviously it's going to be lower than 2.7. That means total number of observation will be lowered. But that's just this. That's my saying. But we need to calculate it, right? So given those information, those are the samples. Then we're going to calculate based on this formulas given. That again, that's from the chapter. So number of observation you need, or in this example, number of cycles we need is just using this. Okay, we just plug in, and Z is the from the normal table we're gonna find. Then S from this, I think is still too small for you guys. S, that's the standard deviation, which is given. Then A, there's the accuracy. It talks about 2%, that's the accuracy. Then X bar, there's the sample mean, which is calculated here. Just take that and divide by 6. That was the mean. Then we just plug in and we find how many observation we're going to need. Okay. And somewhere between, 2.57, 2.58. So then I'm talking about the Z-score, so that we can plug in the whole formula. Then we're going to find 36 point, somewhere between. So that's, we can say that 37 observation, I should say 37 cycles we need. So that's something we're going to expect from the chapter 7. Chapter 8 is location planning, comparing different location, right? Cities, in this example, 2 cities, based on costs, revenue, and profit and demand, right? Because that's what we're going to use here, all these calculations and formulas and equations. Again, those equations will be given. Equations and formulas will be provided. So just so that you can, you can use it or you can manipulate it based on the question. But
can I ask you a question?
Sure.
Yeah. From the previous task, how do we know the Z-score? Is this just something we have to memorize?
No, either Z-score will be given in terms of the table.
Okay, perfect.
Yeah, if you need it, I'm going to provide a table, of course. All right. So that you don't have to worry about that one. All right. All right. Moving on here. So total costs, profit, so that we can kind of, moving this equations from left to right, and then eventually we're going to find the profit. Okay, so which has the higher profit? There you go. One has a higher profit, which is Kansas City in this example. So that's the one kind of problem we're going to have, finding the highest profit or higher profit, comparing those two. And the other one is, if you recall, sandwich shop, right? They're considering 3 locations, A, B, C, and based on the, costs, variable cost or fixed cost, and the price, of course. It's a given, just like that. Then again, we're going to plug into formulas and equations. And we're going to find a Q in this time, right? So we have Q for the location A, Q for location B, and C, and then we can determine. And B is profit, okay? Finding expected profit again using the same equation from the previous steps it's given. Then calculate, and there you go. You're going to find the greatest profit. So that's another kinds of using those formulas. Third one, well, I don't know, make it too complicated, but I think there's something, this is very similar, but only difference is the question is somewhat a little different, okay? At what volume of output will be the two locations have the same total cost? So that we can put this total cost into equation and set it as just like that, so that we can solve for the Q, so that we'll find the output, right? The volume that can be those two locations have the exact costs. Okay, so that would be 120 units, so that those two locations have the exact same costs. So that's chapter, what was that? Chapter 9? Chapter 8, 9, where is the 9? And this chapter 9? No, this is chapter 1. Let's go back. Yeah, that was chapter 8. Chapter 9 is, okay, check sheets and Pareto chart on one chart. There you go. So if you recall, we just had all those samples and given the ticket number, so that what has been done, and it's not like a number of items, but it's showing, what are the contents or what are the work, so that we can kind of consolidate it into histogram in this example. I think the textbook says Pareto chart, but Pareto chart and histograms are almost same. Only difference is, since we're going to use Excel, then if you go to chart design and change chart type, and what I'm having is histogram, but right by histogram we have Pareto chart, which is same histogram, but only difference is give you the line, kind of give you, the giving the tendency of that data set. So if you recall, in terms of organize the total number of items, I use the counting function rather than count. I wonder how many data sets are we going to have, assuming if I'm going to give you like 100 or 200 data set, you're not going to just manually count it, right? So that's why I'm using countif function. I think you should use countif function to do, to organize this questions like this. Okay, so that you can do it quicker rather than counting manually. Then all you do is just put it into histogram. And problem 2 of that chapter 9 was almost same thing, but it has more data set and become a little bit more complicated because of of the data has combination of words and numbers, for example, but this one, it has FNR divided by a slash, so it becomes a little bit complicated. That's why, let's see what I used here. Oh, I still use the counting function. Okay. Don't worry about this. I just kind of overdid it here. Counting function to organize this data and put it into this table so that I can quickly create histogram. Insert recommended chart. Histogram is right here. Even parrot chart is fine too. So that's the chapter 9 in terms of check sheets and histogram or Pareto chart. Chapter 10.
Can I ask one thing about chapter 9?
Sure.
One thing that confused me that I missed on the quiz for the run charts.
Mm-hmm.
So I thought you never count the first run. So you start the second one that goes either up or down would be number 1. Mm. But is that only applicable when it specifically says up or down counting? Otherwise, if it's just how many runs are there, you do count the first one?
Well, I think we should clarify. I mean, depending on when and how you're going to use it. So I think if you want to use a run chart, the prompt must showing that, whether you start from the first one or not. So if this comes
right.
in the test, I'm gonna clarify, how to start with it.
Oh, thank you. Okay.
Rather than guessing,
Got it. Thank you.
Okay, no problem. Chapter 10. Show. Here we go. Chapter 10. I'm going to show the Excel. So chapter 10 we had 3 problems in the assignment. The first problem is, if you recall, filling bottles, right? Like cola bottles. So they're going to measure the quality, how accurately the test is done. So they measure it, and the mean is supposed to be 1 liter, right? The bottle should be 1 liter, but somehow they're allowed to have a little bit of flexibility with a 0.01 liter. That's standard deviation, right? And we have sample size of 25 to measure the quality. And here's a 2 set that they have run for the samples. Says set A and set B. Right? So the question from here is, what are the upper control limit and lower control limit, and all those random sample goes into? Okay. Again, that depending on the accuracy. The confidence level, right? Confidence level we have is 97%. Because of we have confidence level and sample means and standard deviation, we are talking about z-scores. Okay, so that's something we're going to use in normal table as well. So that's kind of story of this question. And again, the main thing we're trying to do is trying to determine the upper level and lower level for those means goes into. So if it means within those limits, then you're good. The means are outside, then those processes are out of control. So that's the story of this question. So again, all those necessary formulas are given, as you can see, standard deviation, and you have an upper control limit, lower control limit will be given so that you can plug in. And the same thing, the normal table will be given, or z-score will be given if it's more simpler, so that you can plug into this formula. Then what you're going to have is just those two numbers for the upper and lower, as you can see right here. And remember, not only those two numbers, we need to plot means and all those center line with those limits into chart. So that's why we have here. So that's why I organize this way. Something you need to think about this, okay? Think this way is better than you gonna organize maybe vertically or different way. So you have a mean, upper control limit, center line, which is the sample mean. Then you have a lower control limit. Then you have a 1 through 6, those number of items. So just highlight. Then I went to the Insert tab, recommended chart. And from there I chose this one, which just makes sense. Then I changed the our mean, the sample means, by select from chart design. No, we don't have to go to chart design. Just select it. Then I went to change chart type, right? That's what I did. So that I can change into different type of chart. Okay, so that's what I have here. It's supposed to be, when I created in first place, it's supposed to be like that. So all the lines, right? So to distinguish this, that's something we need to show whether it's in or out. So I just changed it to change chart type and change this mean into scatter so that I can show it kind of more clearly, right? So that's the first set. And second set, then we have all that UCL, LCL, then put it into the plot. All right. The second problem of the chapter we recalled as wiper blades. So how many minutes it's taking to replace wiper blades? I think that was the question. So the main thing here is that, again, those sample that we have, whether it is within the limit, upper limit, lower limit, okay? Same thing, the range. Is range also within limit? Remember, a range is just maximum minus minimum, right? Maximum number minus minimum. The range also in the limit. That's what we're going to measure by plugging to formula. Formula is given. And this time, this formula is a little different because we have A2, which is kind of constant, just like a weights. So we have different weights for this equation. So we plug in. Again, this will be given if it's needed. And we plug in, then we find upper limit and lower limit. Okay. And for the range, same thing. The constant for this range formulas are a little different because they have D4, D3. Again, that's right here is given. So that we can plug in as well as other variables. Okay. Then we'll get the upper control limit for the range, lower control limit for the range, and we can plot our samples and see whether they are within or out of limits. So main thing here is just plug in, then you organize your data just like that so that you can plot into the chart nicely. So I think that's going to be it for chapter 10. Okay. I think that's the last chapter. Yeah. So that's what I have. Any questions?
I don't think
I think-
so.
Yeah,
Yeah.
I'm good too, Professor.
We are good?
Yep.
All right. So anything come up and have questions, let me know, okay?
Thank you.
All right. Take care. Have a nice one.
You too.
Bye-bye.
Bye-bye.
Thanks. Bye-bye.
Bye-bye.